Today we are going to discuss about flow meter. Flow meter is used for measuring the flow rate. Flow measurement is the quantification of the bulk fluid movement. Flow may be measured by measuring the velocity of the fluid over a known area. There are different types of flow meters. Electromagnetic flow meters and ultrasonic flow meters are specified in the teaching syllabus. Other types also there. Different types are obstruction type, inferential type, positive displacement flow meters, fluid dynamic or vortex shedding type, anemometer, and mass flow meters. Let us see about the magnetic flow meters and ultrasonic flow meters. What is a magnetic flow meter? Magnetic flow meter is also called magnetometer or electromagnetic flow meter. It is a transducer that measures fluid flow by the voltage induced across the liquid by its flow to a magnetic field. The principle behind the working of magnetic flow meter is Faraday's law of electromagnetic induction. What is Faraday's law of electromagnetic induction? Whenever the flux linked with the conductor changes, an EMF is induced in it. Let us see what is it. Here the blue colored ones are the magnets and B represent the magnetic field. In yellow color shows V. Here it shows the direction of flow and the direction and the V represents the velocity of the flow. Whenever the flow velocity or flow rate changes, B, that is a magnetic field, changes. When the magnetic field changes, an EMF is induced in the conductor placed, and this EMF is directly proportional or in terms of it related with the flow rate. Therefore, by measuring the induced voltage, we can measure the flow. Let us see a magnetic flow meter working. The measured liquid must be water-based or conductive. This makes the magnetometer a great choice for wastewater or processed water. Magnetometers are volumetric meters having no moving parts. This is ideal for those areas where you wouldn't want to be exposed to the measured liquid while working on the meters. It works on the principles of Faraday's formula. Voltage measure depends upon the average velocity of the liquid times the strength of magnetic field times the length of the conductor. Ultrasonic flow meters. Ultrasonic flow meters are of two types, Doppler and transit time. In both these meters, they use ultrasounds to make measurement. Ultrasonic transit time flow meters measure the difference of the transit time of ultrasonic pulses propagating in and against the direction of flow. If the transit time T up and T down and the distance between the receiving and transmitting transducers are L and the inclination angle alpha, then we can write the equation, that is the velocity of flow is equal to L by 2 sin alpha T up minus T down by T up into T down. We can also measure the velocity of the ultrasound signal used or the velocity of the sound path, that is equal to L by 2 T up plus T down divided by T up into T down. With wide beam illumination transit time ultrasound, it can also be used to measure the volume flow independent of the cross-sectional area of the vessel. That is, even we can measure the volume of flow. Ultrasonic Doppler flow meters are other type of ultrasonic meters They work on the principle of Doppler effect. The flow meters measure the Doppler shift resulting from the reflecting and ultrasonic beam of the particulates in the flowing fluid. Here, it measures the difference in frequency or frequency shift between transmitted and received signal. In both this type of meters, they use ultrasound, but the main difference is that for the Doppler principle to work, there must be a high enough density of sonically reflective materials such as solid particles or air bubbles suspended in the fluid. This is in direct contrast to the ultrasonic transit time flow meters, where bubbles and solid particles reduce the accuracy of the measurement. There are many advantages for ultrasonic flow meter. They can effectively measure the flow rates for a wide variety of fluids as long as the speed of sound through that fluid is known. For example, we can measure the flow of natural gas, blood, etc. One can also calculate the expected speed of sound for a given fluid. This can be compared to the speed of sound empirically measured by ultrasonic flow meters. That is, a drop in the quality or change in the measured speed of sound indicates that meter needs servicing. This is the pictorial representation of an ultrasonic flow meter. Ultrasonic flow meters. The principle behind ultrasonic flow meters is that an ultrasonic signal is transmitted downstream while another signal is transmitted upstream. The differential time is used to calculate the velocity of the signal. That velocity is then used to calculate the volumetric flow through the pipe. There are mainly two types of flow meters. Ultrasonic flow meters are non-contact means of measuring flow velocity. The Doppler ultrasonic flow meter must have particles or bubbles to reflect the ultrasonic signal. When transmitted into a pipe that contains flowing liquid with such a discontinuities, an ultrasonic pulse or beam reflect from then with a change in frequency that is directly proportional to the liquid flow rate. Transit time ultrasonic flow meters. They measure the time difference between signal transmitted by first transducer and signal received by second transducer. A comparison is made of upstream and downstream measurement. If there is no flow, the travel time will be same in both directions. When flow is present, sound moves faster if traveling in the same direction and slower if moving against it.